MIT Primes has 4 sections. Here are the sections. We want to focus on Yulia's dream, and many problems are similar. Okay, in this video, we'll work on 5 ideas and 9 homeworks. Many problems are in common in these sections. And if you want to learn more ideas, there are around 40-50 important formulas in each topic: combinatorics, algebra, number theory, and geometry. If you want to learn them, if you want to solve related problems, if you want to prepare for any math exam, feel free to send message to my WhatsApp number in the description and comments. Here, idea 1 considering small examples, and idea 2, 3 triangular method, some identities, and use induction. The structure considering small example, find the idea problem from PMO Philippine Mathematical Olympiad, from British Mathematical Olympiad, from USAMO. We have problems and IMO International Mathematical Olympiad. Okay, so let's work on the problems. And as I said, if you had any question, send message to my WhatsApp number. Okay, problem 1, 2, 3. So 4 and 5. We have 5 problems. Let's start with problem, for example, 3. It says let m be a fixed positive integer and consider the following game. At each move, you pick uniformly at random an integer 0 to m. Then you score k points, but only if k doesn't exceed the smallest previously picked number. Otherwise, you don't score any points on that move. For example, if m equals 3 and your random numbers are these, okay, so we get 2 here, but 3 it exceeds from previous. Here it says what doesn't exceed the smallest previously picked number. So 3 exceeds, so we cannot consider that. 1 is good because it doesn't exceed. 2 is not good now because it exceeds from 1. 1 is good again, and then 0. Okay, so 2 plus 1 plus 1 plus 0 here. And it explains. And it has 3 parts. So first part says how much will you score on average if you play indefinitely? Okay, so let's see. For solving these types of problem, idea 1 is to you considering small examples. Considering small example is so much important. Okay, so much important. In IMO, in AMC, AME, USAMO, all of them use. So here we can use a small example on what? For example, on M. Suppose M is 0. Okay, it's obvious. Then in each step you can select K is from 0 to 0. And in this case, answer, let's define it as A, for example. Because we have this definition, let's define it as BM, okay? Our answer, our average. Or because we have a like this, let's consider it AM. So A0 is what? Is 0. If M is 1, it is from 0 in each step, K from 0 to 1. Now try to calculate A1 first on your own. Okay, for A1, we consider, for example, if first one is 0, then if also after that we have some 1s, they have no effect because they exceed 0. So if it starts with 0, if it starts with 1, 1, if it starts with 2 1s. So we are considering the cases that in which step we see 0 for the first time. In first step, second, third, fourth, and so on. So in this part, what's the score we have? 0. What about this part? 1, but the probability is what? First one should be, here the probability was 1/2, but we don't need to write because it has no effect because it is multiplied by 0. 1, 0, the probability 1/2. 1/2, 1/2 squared times 1. Okay, next one is 1/2 squared, 1/2 cubed times 2. Next one, 1/2 to the 4 times 3, and so on. So, if you want to calculate A1, it will be 1/2 squared plus 1/2 cubed plus 1/2 cubed, 1/2 cubed times 2 plus 1/2 to the 4 times 3. And you should calculate this, okay? So, as idea 2, let me tell you a method. When we have 1 plus r squared to r to the n, it is equal to what? R to the n plus 1 minus 1, r minus 1, or we can negate both numerator and denominator by -1. As homework 1, try to prove it. Okay? But here, as you can see, we have some coefficients. For many, I can say, identities, if you have coefficients, you can use triangular method. We call it this. It is what? So, here I write all of them with coefficient 1. 1/2 squared, 1/2 cubed, plus 1/2 to the 4th, and so on. Then 1/2 squared, we had 1 here, we have 1, but from this one we have 2. So we start from 1/2 cubed plus 1/2 to the 4, and so on. Then in next step we start from 1/2 to the 4, and so on. And next part we start from 1/2 to the 5, and so on. Okay, so the first one is what? If we factor from 1/2 squared, it will be what? 1 plus 1/2 plus 1/2 squared, and so on. And here, if we use this identity, when r is, let me write idea 4, when absolute value of r is less than 1, then 1 plus r squared to infinity. Here, this part, r to the infinity plus 1 will be 0. It will be 1 over 1 minus r. And it has also other proofs, homework 2. Try to also prove this. You can consider this s, then multiply r by s. Then you can write an equation in terms of s and find s equals 1 over 1 minus r. So if you use this part by this formula, r is 1/2, so it is 1 over 1 minus 1/2, which is 2. Okay, so it is 2 times 1/2 squared. Next one is what? Is 2 times 1/2 cubed, if we factor from 1/2 cubed. It is 2 times 1/2 to the 4th. It is what? 2 times 1/2 to the 5, and so on. So, A1 equals what? 2 times 1/2 squared is 1/2, plus 2 times 1/2 cubed is 1/2 squared. 2 times 1/2 to the 4 is 1/2 cubed. 2 times 1/2 to the 5. Okay, so look, if you want to learn more identities like this, or if you want to learn 40, 15 formulas in each topic, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, here again we factor from 1/2, it is 1 plus 1/2 plus 1/2 squared, and so on. And if we use again this formula, idea 4, it will be 1/2 times 1 over 1 minus 1/2, which is 1/2 times 2 equals 1. Okay? So we found that A1 is what? A1 is 1. Okay? Now that we found A1, let's try, and you've learned how to use identities. Let's check M2. Okay, consider M2. And like these things here, K is from 0 to 2. Try to find A2 is what? Try first on your own. Okay, so here, when we want to calculate A2, again, we should pay attention to the first time we see 2. So if in first step we see, for example, or first time we see 0 or 1. If in first step we see 0 or 1, for example, like here, that we said in first step we see 0. Then after that, it will be similar to A1. Okay, but the probability that you see 0 or 1 in first step is 2/3 because you can see 0, 1, or 2. 0, 1 are okay, so it's 2/3 of A1. If we see 2 and in next step we see 0 or 1, okay, it will be what? The probability of C2 in first step is 1/3. The probability of C0 or 1 in second step is 2/3. And then it will be 2 here in first step plus A1. Okay? So, okay, try the rest on your own like this. Okay, so here if we see 0 or 1 in third step, it will be what? 1/3, 1/3, 2/3, 1/3 squared times 2/3 times 2 plus 2 plus A1. If we see 3 twos, then 0 or 1. Can you say it will be what? It will be 1/3 cubed times 2/3 times 2 plus 3 twos. 2 plus A1. Okay. And in general, we can say it's 1/3 to the, for example, k times 2/3 times 2k plus A1. Okay? Now, if we add all these numbers, let's first only consider the cases, the terms that have A1. Okay. So it will be what? It will be 2/3. All of them have 2/3. 2/3 A1. 1 plus 2/3 A1, 1/3. Next one is what? 2/3 A1, 1/3 squared. And so on. So again, if we use our identity, 2/3 A1, 1 over 1 minus 1/3, which is 2/3. A1 was what? Was 1 times 3 over 2. So we can cancel, it is 1. Now let's consider the terms that don't have A1. So if you write this, it will be what? We can factor from 2/3, 1/3 times 2. 2 times 1/3 times 2/3, it will be 1 plus. This one is 2 times 2 times 1/3. Okay, because here 1/3 is squared we have, so it's 2 over 3. Next one is what? 3 over 3 squared. Next one is what? 4 over 3 cubed. And last one is what? Look, 2. 2/3, 1/3. It will be 3 to the k minus 1, k over that. Okay. Okay, now try to calculate this. We solved something similar to this in previous part. Try first on your own. For solving this, again, we should use triangular method. So it will be what? It will be 4 over 9 times here. Triangular method was what? At first we consider one coefficient 1 for all of them, 1 over 3 squared, 1 over 3 cubed, and so on. Then we consider from 1/3. Then we consider from 1 3 squared. Okay. So 1 over 3 squared and so on. So here it is what? 1 over 1 minus 1 over 3. which is 3 over 2. This one you can factor from 1/3, and the rest will be like previous line, 3 over 2. Next line will be what? 1 over 3 squared times 3 over 2, and so on. So the answer will be what? Will be 4 over 9 times 3 over 2 times 1 plus 1/3 plus 1 over 3 squared. Again, this one will be like calculating this. 3 over 2. So 2 will be cancelled with 4. 9 with 3, it is 1. So if you add pink part plus blue part, the answer will be 2. So A2 equals 2. So we've calculated A1, we've calculated A1 0, A0 0, A1 1, A2 2. Now, when you calculate like this, you find the idea, we can guess. And then idea 5. When you guess the answer is what? Use induction. Okay, to prove this structure is so much important. Using a small example, then finding the idea, and then use induction. So suppose we know that A0 is 0, A1 is 1, A2 is 2. Suppose up to, for example, AS equals S. Now we want to prove why AS plus 1 equals, or let's say, I can say AS minus 1 equals S minus 1. Now we want to prove AS equals S. Okay, so let's prove this part. Okay, so try this part first on your own. Okay, so let me explain here. I said we consider these things because I think you didn't have audio. If in first step we have 0 to s minus 1, the probability is s minus 1 over s times as minus 1. And if in first step we have s, in second step we have 0 to s minus, oh, so let's do something. We have, sorry, let me correct this. Because we have 0, we can have 0 to s. So s plus 1 cases, s over s plus 1. So let me correct these parts. Okay, so it will be what? It will be 1 over s plus 1 times s over s plus 1 times this 1 over s plus 1 squared. If in first two steps we have ss times s over s plus 1. Then in next step we have 1 over s plus 1 cubed times s over s plus 1. Because of this, the probability as minus 1 plus 3s. Okay, so we know as minus 1 is s minus 1. Try to simplify this and see, will as equals s or not. So try first on your own. Okay, so let's calculate as. Again, at first we calculate the things that have as minus 1. So if you factor from s over s plus 1 times as minus 1, it's 1 plus 1 over s plus 1 plus 1 over s plus 1 squared plus 1 over s plus 1 cubed, and so on. So it will be what? It will be s over s plus 1 times as minus 1 times 1 over 1 minus 1 over s plus. Okay, so it will be s over as plus 1 times as minus 1 times s plus 1 over s plus 1 minus 1s. It will be cancelled. It will be as minus 1, which is s minus 1. Now it is exactly similar to here. When we've calculated this part, it was a1, which is 1. Now let's calculate the next part. Let's consider them as pink parts. Okay, if we consider pink parts, this one, this one, this. So we can factor from s over s plus 1 squared times s. S over s plus 1 squared times s, which is s squared. It will be 1 here plus 2 over s plus 1 plus 3 over s plus 1 squared. Again, we should use triangular method to solve this. Use triangular method and calculate this part. Okay, so let's try together. Inside this part, it will be 1. We can write all of them with coefficient 1. Then we start with 1 plus s over 1. Then we start with 1 over s plus 1 squared. And this part is what? We calculated this part here. It was what? It was this, which is s plus 1 over s. Okay? But here we calculate. Next one, we factor from 1 over s plus 1 times s plus 1 over s. Then we factor from 1 over s plus 1 squared times s plus 1 over s. Then, if in all of them we factor from s plus 1 over s, it will be 1 plus 1 over s plus 1, 1 over s plus 1 squared. So it is s squared plus s plus 1 squared times we factor from s plus 1 over s. Then it will be 1 plus 1 over s plus 1, 1 over s plus 1 squared. Again, it will be like this, s plus 1 over s. And when we multiply, it will be 1. Okay, so it is 1. And the blue part was what? The blue part, let's see here. AS minus 1. So AS we proved is AS minus 1 plus 1. By induction, it was S minus 1 plus 1 will be S. Okay. So we solved this problem completely. Part 1, Part 2, and 3. And as I said, if you want to learn more ideas, we set idea up to idea 4. If you want idea 5. If you want to learn more ideas, 40, 50 important formulas and ideas in geometry, algebra, number theory, combinatorics. If you want to learn them or prepare for other math exams, feel free to send message to my WhatsApp number in the description comments. Okay, so we had 5 ideas. And I told you some homeworks to prove them. Homework 2. You can do this one as homework 3, homework 4, and I can tell you also some other homeworks similar to this one. Homework 5 is from PMO Philippine Mathematical Olympiad. Okay, for working with theories like these that we solve in this problem, a small example, this problem is so much similar Philippine Mathematical Olympiad. It was for 2023 or 2022. Okay, try this problem. We have also some homeworks on in BMO2. I released the solution of BMO2 2023. I can say homework 6 and homework 7. Two of the problems can be solved with this idea. Two of the problems are related to combinatorics. Okay, one of them invariant, and for example, a small example, an induction, exactly same structure, and the other one was some problem related to MK. You can see my previous videos. BMO is for British Mathematical Olympiad. Homework 8, I released USAMO 2023 solutions. Some of them could be solved with exactly small examples. And also in those problems, I released some related problems from IMO. Okay, from IMO that can be solved with the small examples. Also in IMO 2023, we had similar problems. I released solution of them. Okay, so here, 9 homeworks. If you want to know exactly the homeworks are what, or want to learn more ideas, or want to prepare for any math exam, feel free to send message to my WhatsApp number in the description and comments. Okay, 9 homeworks. Okay, 5 ideas, 9 homeworks. Okay, thanks for watching this video. Have a good day. Bye.